So let's take a look at what we were able to complete last week. Let me share my screen. So last week we were able to create this, right? So we basically have most of our things completed, and we could reasonably finish this either this week or next week. So we have like the player jumping up and down. We can move it like, oops, I messed up. So we just have kind of like the finishing touches to work on. So we'll do that this week, and we'll try to, and we'll see if you guys want to like work on something new next week. Does that sound like interesting? Maybe like a small project, or we can do CCC preparation. What do we say? Don't know? Okay, that's fine. Okay. So like one easy thing that we can add to the game would be like kind of like how far we've got through the level. So if we go into game.py and we go to our draw function, we can quickly make that. So we need to first like keep track of how much of the game have we already completed. So let's make a variable for that. So completion is going to equal self.player.position.x minus self.player.start.position.x divide by self.goal.position.x minus self.player.start.position.x. Okay, so I just wrote out this entire thing here. Let me explain what this is. So we need to make this variable start position. So let's do that quickly. So I just copied that, and I'm going up to my init function, and I'm just going to paste in self.player start position is equal to self.player.position at the start, right? Did we already make? No, we didn't make a variable for that yet. So what we're just gonna just do is a Pygame vector2 of this. Perfect. And then we can use that in the completion. So we need to do this for a reason here. So if you were to have your game like this, right? Your goal is obviously at the end here, right? So this X position. And then we have the player starting over here. So this is the player's X position. We need to find how far we are along this map. So what we're gonna do is we're just gonna like remove this area here. I'm just gonna like kind of not think about that. So what we did is we essentially subtracted by the player's start position. So this is start position here, right? This length. And then what we're doing is we're kind of just considering how far are we along here. So what we have is this value divide by this value. Now, if this was 0 and this was 100, right? If you were, for example, I don't know, right in the middle, we go 50% of the way, right? So let's say this was x is equal to 100, this is x equals 0. If this was x equals 50, so what we do is 50 divide by 100, and that gives you 0.5. 50% of the way along the path. And when we were to reach like when x equals 100 for the player, it'll be 100 over 100 equals 100%, right? So in this way, we'll be able to find a percentage of how much we've passed, how much we've completed. So now we do pygame draw okay, no. Did we make the fonts yet? Yeah, we did. So before we made a font, so what we can do is use this font to make some text in our game. So we do completion underscore text equal to font.render, and we want to turn we want to find how far are we like along the way. So we'll do string int of our value, so completion, right? That completion percent, and we'll do this. Actually, let's just make this into an f string. So f string. So an f string will let you like put like stuff, like you can make a string here, and if you want to put a variable inside, you put these curly braces. You put completion in here. I will put a percent, and I guess we'll round this value to the second decimal place, just to make it slightly easier for us to read. So there's that. So what this is going to give us is a fraction of how far are we along. So this would be like the 50 over 100, right? Which will give us 0.5. We need to convert this to percent, so all we need to do is just times 100. And then we also want to make sure that this is anti-aliased, and we're just going to make it white. And then so when you render, you need firstly what you want to render, so the text, so this number here, and then we want to know if it's anti-aliased or not, and yeah, it is. And finally, what color? So 255, that's white. And then we want to do screen.blitz completion text, comma, and then we want to put it like right at the center of the screen. So what we're going to do is screen width divided by 2 minus completion text, text.get underscore width divided by 2, comma 12 plus 15 divided by 2 minus completion text dot completion text dot get underscore height divided by 2. And now I'll explain this. So when we're like making graphics in a game and like making different like menu items and icons, it's pretty important to have a good sense of like where we're putting things. So we want to put this text that says like how far along that we are, like someplace. We want to put it someplace where we can easily see it. So, oh yes, yeah. So if we were to run this, right, as you can see, it'll give us a number at the top. How far along are we along the way? If I can get past like 8%, that's pretty cool. Right, but sometimes it gives us like a really long number, and that's kind of weird. So what we'll do is we will just round it to that value, and then when we multiply by 100, that should give us, oh no. Okay, what if we multiply it first by 100 and then round it? There we go, that works. So slowly count up, and as we go further in the level, you'll see that this is going a lot farther. So let me explain. So as you can see, it was right in the middle of the screen, so like we had like 10% at the top here. Now how did we get that? Well, firstly, screen width minus completion text dot get width divided by 2. Okay, well the screen width right in the middle of the screen, right? And we centered our text around this line here. How did we do that? Well, we took the fact that our text is like a box here. This box represents the area that the text takes up. If we take half of this box right here then we're able to go to this spot here, which will center our text in the middle of the screen. So that's how we got it centered on the X. And then we just had 12 plus 15 over 2. So that's 12 plus 7.5, so that's plus 19.5. So this is just a number that I chose. And what we're going to do is we're going to make like a little line to show like our completion, how much we've completed already. Right, so this would be 12, so we're just going like this far down, right? And then we're subtracting a certain amount to put us like right here, okay? And that'll leave us some room for the line. So let's do that quickly. So we know how far through the level we've gone, this variable right here. If you do pygame.draw.rect, and we put it on the screen, and we make the color just like this red color. It's going to be kind of dark because it's 128 only. And we're going to put it on the screen width, divide by 6, minus 3, and then 12 minus 3, comma screen width times 2 divided by 3, plus 6, comma 15 plus 6, and we're going to say border radius equal to 10. There you go. If you run that, you'll see that it's going to put this big bar here, and this bar is just going to show like this is just going to be like the background, and we're going to have another line going across to show us like how much through the actual level we've made it. So what we can do is we can literally just copy this, paste it on the next line, and we'll use C55 here. And instead of our thing over here, I'm going to explain this in a minute, this 12 minus 3, what we can do instead will be 12, right? And then we will calculate how far along are we in the level. So then we will do completion times screen width times 2 divided by 3. As you can see, the bar is filling up. I think I just put it a little bit in the wrong spot. This should be just 15 over here. And I think it's a little bit offset. Should be just screen width divided by 6. Yeah. There we go. So now I'll explain what I did. So as you can see, as you continue through the level, the progress bar will slowly fill up, and the amount of progress we made through the level will also go up. So that's pretty cool to see like just how far are we along the level. So like just being able to like recognize where to put these, where to put like the different GUI elements, like we're putting like where to put like specifically this rectangle here, is really important to be able to understand how these are related to each other. So I can explain it right now. So I just beat the level, it'll show me 100%. Okay, so let me explain these two lines. So what we did is we drew a rectangle, and if you put this parameter border radius, it will make the rectangle look slightly curved. And then we put 128, so this is the background one. Now we have to make this one slightly bigger than this one right here. So that's why we have this minus 3 and this minus 3 over here, and this plus 6 and plus 6, because what we're doing is we put like this, the one that fills up goes right here, right? But then the one that we want to do as the background, it has to be 3 pixels bigger than the other one. So how do we do that? We put the X and Y position, subtract 3, so that will put us over here. And then we have to add 6 for the length and the height, so that we encapsulate both the top and the bottom one, the extra padding. So we just had screen width divided by 6 minus 3, right? And 12 was just a random number I chose that works well. And then we had screen width times 2 over 3. So we're saying that 2/3 of the screen is going to be filled up by that bar. And then we're going to be adding 6 for that extra padding. And then if we look at the next one, the one that fills up, if you see here, we have screen width divided by 6, but we don't have the minus 3 because we actually want to start it there and it'll look slightly padded. If you can see like that, there's like a slight bit of dark red around it. And then, right, we want to put it at 12, so it's just a number that worked well. And we had completion times screen width times 2 over 3. So our completion, this is like a fraction between 0 and 1. So any number you put in here, right, is going to be like a fraction. So something like 0.5 or 0.25, right? And we know that our full distance is going to be equal to, I don't know, let's say like 100 for now, right? So this is in reality screen width times 2 over 3, right? But let's say like we just have like one of these values, right? If you multiply 0.5 times 100, will give you 50. Where does 50 put you? If this is 0, this will put you halfway, 50, right? If you got 0.25 for your completion, multiplied by 100, you're going to get 25. 25 will put you right here, right? So if you completed 25%, then you've completed this much. If you completed 50%, then this is halfway, you completed that much, right? So this way we can scale how much our bar goes up by using this completion factor times the screen width divided by 2. And of course we have 15 here because that's just the height that I found that worked well. And excuse me. But yeah, that's just like a small little thing that we can do, and it makes the game look a lot nicer. So yeah. The next thing that we can do, I'm actually going to change the level to level 1, just for testing purposes. Alright, so as you can see, this also works for all different levels. And right, this is the ship level that we tested, and it completes at 100%. What we're gonna do is I'm actually gonna pause the camera moving. So if you guys noticed, when you reach the end in the actual game, like if this is the end here, right, then the camera actually stops moving at this point when it reaches the end, and then the player will start moving itself. Now, how do we do that in our game, right? Because obviously, we are moving the player, but we just need to like stop the camera. Now, how can we do this? So we're going to go into our game, and we need to keep track of a few things. So in game.py, we need to keep track of like when we reach the end, like is the game gonna be over, right? So we go over to, okay, I think yeah, if we go into our update, right, and when we check for whether, oh no, if we go into our player, sorry. Okay. We need to go find where our camera's being moved. right? And then we need to figure out, yeah, okay, I was just looking at the wrong reference. Anyways, okay, so if we go into our init function and we make some new variables, so we'll call this self dot, oh no, this should be in the game.py file. Go to game.py, go into your init function, and we'll do self.end underscore reach is going to equal false, and self.game underscore over is going to equal false as well. So these, we're going to have these two variables here just to keep track of like when we finish the game and when are we going to be like reaching the end. So this end reach variable will be useful for us. So if we go into our game here, we need to find out when will we like kind of reach the end. So if we go down, we need to find out if the goal position. So after we update the goal, and we'll just do it after all this, if self.goal.position.x minus self.player.position.x is smaller than self.player.width times self. So what we're gonna do is we're gonna like figure out like a distance that the goal should pull the player towards itself. So we'll just set the player's velocity and we're gonna divide this by self.goal underscore pull underscore distance times tile dot width divided by 300. Okay, so what we did here is I just kind of went on a little tangent and I added in the abilities so that when you reach the like a certain distance to the goal, so if the goal's position minus the player's position, so goal position minus the player's position, so if this distance is less than or equal to the player width times the goal pull distance. So let's make a variable for that. So I'm just going to go to the top and we'll do goal.pull distance, and we'll just say this is equal to 4 player widths. So if you're like within 4 player widths of the goal, what it's going to do is going to set the velocity.y is going to be equal to the goal's height. Right, so the goal's height divide by 2 minus the player's position. So if we have this is the goal's height divided by 2, this is the player's position. We're going to divide this. So we're going to find this. We're going to find this value. How far are we from the center? Because we're going to like try and pull our player towards the center. And then we're going to find out our distance. So goal pull distance times tile width, and this is just dividing by 300, which is just an arbitrary number. So times tile.width. So this number here is just a number I found that worked well. And basically, like if you are farther away, it's going to pull you in faster until you reach the middle point. And of course, it's going to set the player.jump to equal true, so the player is not able to jump while they're getting pulled in. But back to what we were doing before, which was determining when the goal is here it is. So when we update our goal and we update its position, if self.goal.display underscore position the x is smaller than the screen width minus self.goal.width. So where is this? If we look into our screen, right, and our goal has the display position.x is smaller than the screen minus the goal width. Okay, so screen width minus goal width would be here, right? This line. And if our display position is anywhere here for the goal, what we're gonna do is we're going to set end reach equals true, self.end reached. Well, it's not going to do anything yet because we haven't done anything with this code. So if you were, for example, to reach the end, then we'll say if self.end reached, then simply just don't update the camera position anymore. And you'll see that when we run the code, right, it doesn't work anymore, right? We need to just make sure that, I think we need to set it to true when that should not have done that. End equals true. Okay. Oh, if not end reach. So we haven't reached the end yet, then we still want to update the camera, but once we reach the end, right? So reach the end equals true. Then we want to stop updating this. There you go. So now we're moving. And then when we get near the end, you guys are going to notice that the screen just kind of stops moving, but the player still keeps moving and gets pulled into the goal. So that's just a pretty neat way to just have the level end. So then, yeah, that's like a really cool thing to do. Now let's work on kind of like some, like when the player is like hitting a spike or a wall, we gotta make like some kind of code to make the player like kind of explode in a bunch of particles. So right now the player just like hits it and the game kind of restarts. So let's add in some particles for that. So let's make a new file. I'll call it particle.py. And in this particle.py file, we need to, from setup, import star, make a class def particle, and we need to set a max lifetime. So a max lifetime is equal to 2, and we're going to set our color is equal to red. I'm going to set our outline color is equal to 128, 0, 0. And oops. So this is just some like random variables that we've made that we're going to be using later. So like max lifetime and the color. Now let's make our init function. So this init function, if you guys remember, it will run every time you create a new instance of this class, right? Self, and we need the position. So we need to know the position of where the player died, and then we can put a bunch of particles there. So if we say the length of this particle, so what we're going to do basically is when the player dies, we're just going to, if I can find some space over here, right? When you have the player, when the player dies, it's just going to explode into a bunch of squares. So we need to keep track of a side length to be able to control how these squares are going, and they're just going to go in all directions. Okay. So self.length is equal to random.rand int from 9 to 16. So we actually need to import random, so we'll go to setup, import random. Let's go back to particle. So remember we imported setup here, and we imported random from setup. So then we'll be able to use random in our class over here. And we'll set self.position is equal to pygame.vector2 position minus pygame.vector2 of self.length divided by 2, comma self.length divided by 2. And we'll set the display position. This is going to be equal to pygame.vector2. This is basically the exact same thing. So we'll just copy and paste it. And then self.velocity equal to pygame.vector2 random.randint. And this is just some arbitrary numbers that I picked. So I have minus 150 to 150. So here we're making a vector 2. And this x component is just going to be a random integer between minus 150 and 150. And the y is going to be similar, randint, from minus 900 to 100. So if you guys remember, minus in Pygame means going up, right? And I kind of wanted it to go like boom, up like that. So it's just why we kind of skewed it towards the negative side by having minus 900. And then acceleration can be equal to Pygame dot vector 2, 0, 1, 1900. This is just the same gravity we used for the player. And self.lifetime equal to 0. And then self.on underscore ground equal to false. Alright, now we need to make an update function. And then we will do our draw function. So def update and delta. We're going to need a few things like the delta time, the camera position, the tiles, and the spikes. I don't think we'll have enough time for that, so we'll just do the camera position and delta. So the first thing we'll do is self.lifetime. We're going to add delta. So our lifetime is going to be how long the particle is alive. This is for 2 seconds, right? Remember our delta is in milliseconds. So eventually it'll add up and reach 2 seconds, right? And then self.velocity is going to plus equal self.acceleration times delta, and self.position is going to plus equal self.velocity times delta. So right now we're just quickly going to do this, like we just have our velocity, which is changing as the change in acceleration times delta, right? And then our position is just our velocity times delta, right? Speed times time. And then we'll just say, and just try this for now, and just draw it. So def draw. So pygame.draw .rect, and we're going to draw on the screen with self.color, and then we want to put it at self.display position.x, self.display position.y. So remember, there's the top left corner, and then the length, and self.length for the side lengths of the square. And then we can copy this line, and all we need to do at the end is add width is equal to 1, and change this to outline color. And if we run this code, it's not going to appear yet because we haven't actually imported it into our game. I'm just going to decrease this max lifetime to like 1 second and go over to our game, and at the top we will import it. So from particle, import particle, def particle, and then in our init function we'll do self.particles is equal to this. I guess we can just call this effects, right? It's more general in case we want to add different kinds of effects. And in our updates, after we update our goal, for example, we can do for effects in self.effects, effects.update, and we update the effect. So we need delta and camera position, right? So this is self.display position equals self.position minus camera position. You guys remember that? How we made like the thing according to the camera position. If we go back to our game, so this we just need to pass in delta and self.camera position, and then we'll draw it. So for effects and self.effects, effects dot draw onto the screen, and then now we need to actually like put in some effects. So let's just put in some effects for now. So here we'll just put in def particle, and we're going to put this at the position of the player, so self.player.position, and we're just going to do this 10 times. So I'm just using list comprehension to do this 10 times. And as you can see, there's like a whole bunch of particles there at the start. Let's put in like maybe 100. There we go. At the start, you can see a whole ton of particles over there. Let's put it at like the middle of the screen, so screen. So you guys can see it a bit better. There you go. So, pretty cool. It'll just kind of explode like that. So, let's actually put this like where the player dies. So, how do we figure out where the player dies? Well, let's go into our player class. And in our player class, we keep track of when player is dead, right? So when the player is dead, we need to go, we return this. So if we go into our game and we say player status is equal to this, if our player status is equal to player dead, then what we'll do is we will, instead of immediately returning player dead back to the main loop, what we'll do is we will go and we'll say that we want to just add in our particle effects. So to do that, we will need we will remove this for now. Yeah. And what we need to do is we'll just remove this for now, and we'll say that if not self.game over. So we made a variable called game over before, and what that did is just keeping track of whether or not the game is over, right? And what we're gonna do is if our game is not over, right, then we want to keep updating our player. But if our game is over, we're gonna add like kind of like a short moment where the player just explodes and you can see the particles and stuff. So to do that, we need to just put in these two lines here, and these will get a player status for us. And then if the game is not over, then we will update our player, and then if our end is reached and not self.game over, so if our game is over, then we want to stop moving the camera as well, so we can add that over here. And then for effect in our effects, okay, after our effects, right, if not self.game over and player status is equal to player dead, right? So if we haven't set our game to be over yet, but our player literally just died, then we want to set self.game over is equal to true. So that way this will only happen once when the game is set over to true for the first time. And then we're gonna set the depths. We can do that later. We're just gonna go for I in range, and then just pick the random number. That worked well. And then what we're gonna do is self.effects .append, and we're gonna do depth particle self.player.position plus pygame vector 2 self.player.width divided by 2 and self.player.height divided by 2. So we're just putting this like right at the center of the player, and this what this is going to do is just kind of make like a huge explosion right at where the player dies. You know, pause the screen so that you can like just like see the particles going everywhere. And then if self.game over, then we need to set the game over time. So we have to make this into a variable, but basically we're gonna have to subtract delta because it's just gonna go on for like I believe it's a couple seconds, like 1 second or so. So if this value is smaller than 0, then we'll return command quit. Alright, and if player status equals player win, return command quit as well. So right now we don't have any other levels, so we will have to deal with it when it comes to it. But we need to make our game over time variable, right? So copy this, go up into here, and we'll do self dot game over time is equal to 0. At the top, we'll just set this to 1 second actually. So it'll take 1 second for us to watch it. So as you can see, player will explode and the game will stop. That should have returned something. Should be self.game over time here, sorry. There we go. Okay, now if we run this, player will explode and wait 1 second and it will close the game by command quit. Now you can see that the player was kind of in the way, so we'll just do if not self.game over. So this is in the draw function right here. We're just gonna put this if our game is, if this is, if not self.game over, yeah, then, so if our game is over, then we don't want to draw our player. And boom. So the player will explode into a shower of particles. And this works for all different kinds of situations, right? Cool. So that's about it for today's meeting.